Okay, good morning, everyone. Good morning and welcome. I am Lisa Dulude. I'm the UW Director of Sustainability. And here with me is Dave Woodson.
Hi, everybody. Dave Woodson. I'm the Executive Director of Campus Energy, Utilities, and Operations here at UW.
And we're excited to spend about an hour with you talking about UW's plans and strategy and progress decarbonizing our energy system, specifically here on the Seattle campus. Before we get going, I do just want to note that this session is being recorded and the recording will be posted later on UW's sustainability website for those that want to see it, or if you want to share it with friends or colleagues after this. So we're planning to do this more of a sort of conversational style webinar as opposed to a big slide deck. But that said, I did want to share with all of you where you can find a lot more information on this. So I'm going to pull that up on my screen really quickly. So if you go to UW's sustainability website and go to energy and scroll down to energy transformation, you will find a lot more information here on what we're doing to decarbonize the steam plant here on the Seattle campus. In particular, if you scroll all the way to the bottom, hopefully you're all seeing this, but you'll see the 5-part strategy here, this colorful poster. You'll see different posters for different aspects of the 5-part strategy, and Dave's going to talk about this a little bit more today. But I really encourage everyone to go and check out a lot of the information on our website. Okay. So with that, I'll give just a little bit of context. So Dave has been here for about almost 3 years.
2.5.
2.5 years. Okay.
You can round up, sure.
2.5, yeah. Getting close to 3, and was specifically hired to lead this effort. So Dave oversees campus energy, utilities, and operations, but has done this before. He's decarbonized the steam plant at University of British Columbia, and is here and working to lead the charge to do the same thing here at the University of Washington. We've been at this for a little bit, trying to get the steam plant off of fossil fuels. And as I showed you with the website, there's been a 5-part strategy that's been developed. And the real key element of that, just to give a little bit of context for those that this concept or this effort for the university may be new to you, the concept is to move from a steam system to hot water, so that we can eventually put in commercial heat pumps and electrify that system and get off of fossil fuels, to put it in very basic terms.
Pretty good.
All right, thanks. And you'll also find on our website that there's different legislation, both at the state level and the city level, that's really saying that we need to do this anyway, as a large consumer of fossil fuels and a large emitter of greenhouse gas emissions. So the Climate Commitment Act that was passed not too long ago at the state level, the State Agency Leadership Act is also has been around for a while, and it says the state and any agencies of the state need to reduce their emissions. And then we also have the city of Seattle that has passed really similar legislation to the state that says we want you to conserve energy, and we also want you to decarbonize your system. So very short context. Again, encourage you to visit the website for more information on that. But so my first question to you, Dave, this is our 3rd sort of annual webinar with you since you started at UW. I think it's important on Earth Day to celebrate some of the successes that we've seen. So for this project in particular, for getting the steam plant off fossil fuels, what would you say are some of our successes thus far?
Well, there's been a number, and one I would just add on the legislative side of things. The state also has the Clean Building Performance Standard, and originally that law was written in a way where it was very building specific in terms of how you optimize and make a building more energy efficient. And great piece of legislation, very forward thinking, but extremely challenging for a campus like ours, where we have 170 plus buildings. And one of the successes was last spring when the state passed an amendment to the Clean Building Performance Standard that allowed for a compliance pathway for decarbonizing district energy systems. So really geared towards universities like ourselves, but I'd throw, that also applies to Western Washington and Washington State University, Eastern Washington, Central Washington, amongst others. So so that was a big deal because it lays out a way in which over the next 15 years, we need to put forward our plan by next June. Well, we have to signal this June that we intend to go down this pathway and what buildings are included. And then next June is the starting point for the 15-year plan at the state. Our goal is to do it within 10 years. That was a good starting point. A second, maybe describe this as a marathon. We got a long way to go, but the race has started. And we have had some success in getting funds from the state, proceeds from the CCA program that the state has, their cap and invest program. And we've used those proceeds focused on part one of the strategy, which is being greater on our energy efficiency side of things. So investments into controls upgrades, investments into more metering, so we get a better sense of where energy is being used specifically on campus, and into what we call sort of active energy management. And an specific example of that is where you have simultaneous heating and cooling, but not on purpose.
Right.
So in our world of facilities, typically if the heating system's not working or the cooling system's not working, we're hearing about it. We're getting a complaint or a call that's coming in. But what we don't hear about is when, let's say there's a valve on the heating system that's not working and it doesn't close all the way. And as a result, the hot water still slips by, even though the building system actually isn't calling for it. And that hot water that slips by then fills into coils and goes into spaces and it adds heat. And the cooling system will try to, match that and keep the space at a nice, comfortable 72 degrees. And as a result, there'll be no complaint because the appearance will be that the system is working fine, when in reality, the heating system and cooling system are actually both consuming energy at the same time, fighting each other. And so we can use active energy management to be able to track down those leaky valves and identify which ones need to get replaced so that we don't have this unnecessary use of energy.
So could you talk a little bit about, that's great. It sounds like some of the money that we've already gotten from the state will help with that. About how much money have we received thus far for some of those initial phases of the work?
So that in particular, that was $10 million for what was called energy modernization. We also received, there's actually a lot of really deep things. We also received $5 million to add a chiller to the cooling system. And I don't know, like kind of first, Dave, okay, we're decarbonizing the steam plant for heating, get that, but why are we investing money in the cooling system? And there's two parts. One, for those who've heard me before, I'll talk about cooling really is the same thing as heating. The example I give is your fridge, right? That, your fridge in your kitchen works by, removing the heat from the box, and you got a radiator on the back, and then the waste heat is going into the air of your kitchen. And the same thing happens on campus. We have central plants that have chillers that send cold water out to the campus. And then we pull the heat out of the buildings and we bring that warmer water back to the central plant. And anybody that runs or walks along the Burke-Gilman Trail and hears the roaring sound of the waterfalls, those are our cooling towers, AKA heat throwaway machines. That's from Ted Bohr at Princeton. He's probably got that copyrighted somewhere, so I do have to give a shout out to him on that. But that's what they do. All we're doing is we're taking that heat that we've captured from the cooling system and throwing it away. And so one of the very first opportunities for us on decarbonization is to reclaim that heat, use a heat pump, as you mentioned, instead of, so it's a heat pump that runs on electricity versus a natural gas boiler producing steam. And that's the real big pivot of combustion energy to energy transfer that we're doing. And hence why cooling comes into it. So the only 40% of the buildings on campus are connected to the central cooling system. Other buildings either don't have cooling at all, which was great in Seattle 20 years ago when summer highs were, 72, 75. Not the case today in Seattle, where we get into the 90s and we set records for months of number of days in the 80s. So we have buildings that need cooling that don't have it. We have buildings that were built to cooling standards that aren't strong enough for what needs in today's climate. And we also don't see that, that climate adaptation issue is only going to become more challenging. Anyway, bring that all back to, we got $5 million to add a new chiller in the central plant, and that allows us to, one, bring more waste heat back. It also, there's another play as it relates to electrical use. And that is that we can get greater cooling production for the input of electricity from the larger chillers at the central plant than we can from the chillers that are distributed on the campus. So a theme in our overall plan is, how do we make the best use of the electricity that we do have? And that's just one more thing, and that is that when you're going to decarbonize, almost everybody's decarbonization plan is an electrification one. And the biggest challenge that everyone's running into is not just where do the increased wires of the electricity come from, but what do those electrons look like, and how clean and dirty and what time of day and what month of the year and how expensive they are, right? Right now, Seattle City Light, who we get our electricity from, has a January peak. So it's really expensive when they have to go onto the market and buy the extra electricity in January. That's one of the things that drove a 10% increase in our electrical rates in 2024. And so that's a challenge. So we need to be conscientious with respect to how we use electricity in the first place. And so anyway, bring that all back. Yeah, $5 million for a chiller. We've got that already. And that's a nice input into our overall strategy. Fits with strategy number 3, which is centralized cooling. But it's in keeping with this idea of mitigating our impact on the electrical grid and also bringing all of that waste heat back to the campus.
Yes.
That was that. We also got $3 million to take, what we've laid out, the 5-point energy strategy, which is, principally based of what we're wanting to achieve. But there's an element of saying, well, we got to get from that strategy to the actual implementation plan. What are the projects that we're going to do? What's the order of the projects that we're going to do, over the next 10 years to achieve what we're going to achieve? And so we receive funding specifically for the implementation, or to creating that implementation plan. And we're the halfway mark, just past the halfway mark with respect to that exercise. We're looking end of September, or October 1st is the targeted date for having an implementation plan fully baked and ready to go. So that's another exciting one. The other part that I almost take for granted now, but it's something that we shouldn't, because you and I have worked really well on this, of like the whole socialization and communication of the plan. As you see, it gets really complicated really quick, right? Like, it's like, okay, Dave, we're talking about decarbonization, and all of a sudden you're talking about cooling and you're talking about electricity, like all these other pieces. And the reality is you can't just address one utility by itself. They all coincide together. You're gonna, sure, hey, we could electrify, we could, just put in electrical equipment everywhere, but at a 1-to-1 electrical ratio, it would put massive pressure on the electrical grid. And so that's not what we want to do. We want to be very thoughtful. And even, not all heat pumps are the same. We want to maximize the coefficient of performance of our heat pumps, which basically is for the amount of electricity input energy goes in, how much energy do we get out? And we want at least a 3-to-1 ratio, if not higher. And the reason why we want a 3-to-1 ratio is because that about at 3-to-1, that would offset the fact that electricity is typically more expensive than natural gas. But if we have at least a 3-to-1 ratio on that COP of the heat pump, that makes it a wash. And if we get a COP of 5 or 6 or higher, well, now it's actually costing us less money, and that's a win.
Yeah.
So there's the principles of what we're trying to do, right? Switch from combustion to energy transfer, but then there's the nuances of, how do you actually optimize this so that it's cost effective as we move forward.
Yeah, okay, great. And I thought I'd just chime in for folks that may not be aware of this, but we're very fortunate here in Seattle and in the Pacific Northwest that most of our electricity is from hydropower. So if we were in a different state that say burned coal to produce electricity, that, this might not be our strategy, but we're fortunate here that we do have a clean source of electricity, which is why we're electrifying.
Yeah, I think there's a bit of a pivot. Like I think almost everybody's relying on that the electrical grid is going to become cleaner or become 100% clean. I mean, even in the state of Washington, there's legislation.
Yes.
So it's right, the Clean Energy Transformation Act that says by 2045, all the electrical utilities need to be providing green electricity. Now, as you mentioned, we're really fortunate. Seattle City Light, very forward-thinking organization. They have access to their own electrical power, and yeah, they're already very close on compliance with respect to that state law.
Yeah, yeah.
And so what it means for us is that's great. We still have to be cognizant of the incremental electricity. So what I mean by that is, today in the wintertime, we're burning natural gas to provide heat for our buildings. In our future, we're going to be running heat pumps that run off electricity. And no matter how efficient those heat pumps are, it's still going to be an incremental amount of electricity in comparison to the natural gas that we burn today. And the question is, how clean is that incremental new electricity? And so as we, amongst other people in the region, decarbonize and electrify, and we put pressure on the electrical companies who are already trying to become 100% clean.
They're required to.
They're required to, but now they also need to be clean with that incremental electrical load that we're providing them. So that we're putting on them in our plan. So anything that we can do to mitigate that is, we'll benefit from lower pricing. But they'll benefit from their ability to secure it. And so we can't talk about decarbonization without talking about its impact on the electricity and electrical grid.
Yeah. Yep. Great. So I want to bring it back a little bit and just summarize for folks. So some of the successes you talked about is we have a good amount of money to get that has gotten us started. We've hired a consultant, AEI, and a group of sub-consultants to get this implementation plan going. To figure out what projects we need to do and in what order. There's a couple other things that I wanted you to talk about. So the power plant resiliency project.
Oh my gosh, I can't believe I didn't bring that up first.
Also, and we'll get to this, but just some of the in the capital budget process here at UW. We've seen some successes there as well.
Totally. Okay. All right. Yes. Back to the power plant resiliency project. So this was actually an initiative that had started before I arrived. So kudos to the team that pulled this together. But in essence, it was a reaction to the fact that some of the older boilers, from 1948, weren't as reliable or as dependable as one might hope them to be. Which is what happens when you're relying on 1948 boilers, by the way, just as a side. And so the concern was that, hey, when we go to do this great decarbonization project that, we're even accelerating, it's going to take a decade. And when we need the steam system for critical processes, at the hospital and in research areas. And so we need to ensure that we have a reliable system at a minimum for that decade while we go through this transition. And so the team came up with a really, really creative project that basically standardized all 5 boilers at the same pressure. Previously, 2 were superheated, and I'm not going into too technical detail, but basically, because they were producing steam at different pressures, it meant that from a contingency standpoint, you didn't have the same backup capacity, and at both at the superheated and at the regular pressure, they were relying on the oldest boilers as backup for if the main ones went down. Big story long. The effect of the project, so it's a $27 million project, but one of the big wins was that because they're all standardized, it means that the staff can now base load on the 2 newest, most efficient boilers. And at the first year of operation of the new system, we saw a 12% reduction in natural gas consumption, which corresponds to just over 10,000 tons of greenhouse gas emission reduction, which is huge.
Yeah.
And a great early win in the context of our project. You know, we still have 75,000 tons to go, which is what all of this other effort is going to yield, but a nice 10,000 ton reduction as a result of that project. And yeah, and and made the plant more resilient. I mean, it's covering the initial focus, which is to ensure that we've got reliable steam to the hospital and to other research areas for a minimum of the decade while we carry out the project. So
that's huge.
Really neat one. And then on the capital planning side, so in the university's own sort of processes of how capital projects are pulled together, one of the key, if we want to, and we do, really get this rolling in terms of large capital investments in the 25-27 biennium, which starts July 2025. That process actually started in August of 2023. And so, it's great. We got AEI building the implementation plan that we've done in October of 2024. But we needed inputs ahead of that. And there was a major process involving the capital planning process that happens through January and February. And in that, there was, we put in a major, the first
large request.
Like $292 million worth of program as it relates to this initiative to start July 1st, 2025. And it was ranked the #1 project through that process. And I don't know for certain, but I highly suspect that that's the first time a utility infrastructure project was ranked #1 priority by the university's capital planning process. So
well, that's huge.
So
that's great.
Now the pressure's on. Because the element is they've agreed to the projects in principle, but we still have to get the funding. And we have a number of strategies on that front, but the pressure's on us to get to the funding so that work starts July 1st. But another really big win.
Okay, awesome. So tons of wins to celebrate, and I want to highlight just a few others when we talk about. So Dave talked about how we've, in terms of actually getting funding and getting, program implementation ready with AEI's plan. There's been great successes there. And then on the socializing the initiative, really getting folks to understand the significance and the importance of getting the steam plant off of fossil fuels. There's been just a few others. Campus Energy and Utilities, as well as UW Sustainability, partnered with the Faculty Senate and hosted a decarbonization town hall last fall, which is on that website that I showed everyone. Encourage folks to go and watch that. But that was very instrumental, I think, in just giving a platform and a place to have a discussion and have a discourse about sort of the magnitude of this project and what it would mean for the university. And then the faculty senate also, sort of as a follow-on to that, decarbonization town hall passed a resolution. Do you want to talk or just give a quick overview of the resolution that was recently passed?
I mean, I think I'd put it in the context of we're trying to be really transparent with what our approach is and what we think is reasonable and what makes sense to do. And we've every opportunity we've had just like this to come out and tell our story. And which then got reinforced with the decarbonization town hall. And then in the course of that legislation, it's reinforcing and encouraging to hear from whether it's the graduate students or the faculty how important this is to them. So we feel like we're acting in an appropriate way from an administrative stance in response to that, but also feel like and I'll throw the students into this as well, right? They had their protest in May where a handful of them chained themselves to the power plant. No one got hurt, so that was good. I would not encourage that behavior whatsoever. That being said, the message that I clearly took from that was, Dave, like the plan, go faster. And I think that's really the same message coming out of the legislation from the faculty of, like what you're doing, but go faster. And, and really, emphasizing this idea of 95% by 2035.
Yeah.
And so
for folks on the online, reducing 95% of our direct emissions.
Right.
So from fossil fuels that we burn by 2035. Yeah.
Right.
Yeah.
And exactly. So so that's and I think there's an element of like we know what we need to do.
Yeah.
We've started we're the race is on. The marathon's going.
Yeah.
Training sessions are over. We've been eating well and we're ready to go, and we haven't got to the first mile marker yet, but we're feeling really good that we've been doing all the right things and that we're in a really good spot to finish this race out.
Yeah, and that's a perfect transition to my next question for you. So we know that for this project, we can't go to Lowe's or Home Depot and buy the thing off the shelf and just plunk it into the steam plant. This is going to be a major infrastructure project. So, we're very fortunate that we have this central plant, and we have 8 miles of tunnel already built underground to distribute this energy.
Yeah.
So we've made a lot of progress. And what can you tell us about what's ahead? What's coming this next year in terms of next steps in implementing the project and keeping things rolling?
Yeah, sure. Well, obviously, finishing off the implementation plan is a key one. Securing the funding at a minimum for the first biennium's worth of projects is second. But I'd also, we're learning a lot. Obviously we laid out the 5-point strategy, and I feel like I should just take a step back because maybe not everybody knows just a couple elements of it, right? We talked about the fact that it's using heat pumps and electricity versus natural gas and boilers, but there's an element of those heat pumps have to exchange with they have to get their heat from somewhere, some source. Yeah. And you could say air source, but we actually are we'd rather have a water source heat pump because they're more efficient, better COP. We keep coming back to that one. And so our big target areas are the waste heat from the cooling system that I spoke to. The second is waste heat from the regional sewer lines, and working with King County on accessing those. And third being the lake, from not just a heating standpoint, but also cooling. But just to give a flavor of, one of the things that we've learned is the waste heat from the cooling system and the waste heat from the sewer represents almost 70% of the heat load or the displaced heat load of the campus. So the two of them don't solve the answer, and no one piece solves the answer. 70% is pretty good, right? In terms of the reduction. So so that was really encouraging. And the other part that I highlight in that, and there's a couple of things. One, the initial engagement with King County, super positive, really encouraged with that.
Do you want to talk a little bit, just so folks know that King County has a pilot program
Oh, right, yeah.
for waste sewer heat recovery.
Yep.
They're essentially putting out come apply. We're going to have sort of a pilot program with 3 organizations or 3 test projects. So you want to
I kind of compare it's like the Charlie and the Chocolate Factory and the Wonka golden tickets. So in this case, there's only 3. 1 has been claimed already, and there's 2 left.
We're trying to get,
and we want to be one of those golden tickets. And so they have a requirement with respect to having a 30% design completion of what that looks like, and so we're keen to get one of those golden tickets, be part of it, because you can see it could be such an instrumental part of our strategy. And once again, just to take a step back, when we talk about waste heat from the sewer, we're talking about like when you take a shower in the morning, or you go and you wash your hands at the sink, and that warm water that's just going down the drain. It's the heat in that warm water is what we're going after. And what is unique about our location is the fact that we're in an urban setting inside the city, and we have access to those rather large regional transmission lines that go adjacent to our campus. And so that opportunity doesn't exist everywhere, but it exists here. And so for us, it really is a bit of a no-brainer to use it as a displacement on our natural gas.
Yeah, great. I'm noticing a few questions from the chat. I'll bring up sort of the theme of one of them as opposed to the question itself.
Okay, sure.
But it's around energy efficiency. And I think, you addressed this in some ways earlier when you were talking, but can you just talk about where energy efficiency fits into our strategy?
Well, it's kind of number one. Like it is like it's part one of the strategy is number one thing, because it's the element of saying, the most cost-effective energy is the energy you don't need to use in the first place. And I spoke to the idea around active energy management and simultaneous heating and cooling. I think another one that's really obvious to us is well, not obvious, but subtle but important. When you look at our electrical demand for the campus, you'll note that if you look at it for a year on a daily cycle, the university peaks at like 50 megawatts of energy, but the minimum is 26 megawatts of energy, meaning that at 2 o'clock in the morning, there's 26, half of our electricity that we would use on a peak summer day is getting used every day of the year. And so why is that? And so that represents an opportunity. So before we add capacity and put greater pressure on Seattle City Light, what can we do to make better use of what's happening at 2 o'clock in the morning on campus? And the obvious, the one we're focusing on is air changes per hour in research spaces. And now there's standards for that of, that there should be between 5 and 8 air changes per hour, meaning if you're in a space like our office, if there was 5 air changes per hour, it means every 12 minutes, all the air in this room comes out and new air comes in, and that new air has to be heated or cooled, and all that heated and cooled air every 12 minutes goes out the door. Now, flip side is if you're having air changes every 12 air changes per hour, every 5 minutes, all that hot and cold air is going out the door. And so that represents an opportunity. One, not just what's the optimum number of air changes per hour, but also the fact that in the same way that we just dump the heat out at the cooling towers with our heat throwaway machines, we're also dumping all of that heat and cooling out the window at those lab spaces. And so there's an opportunity to recover that and reuse that energy, and not just at the building level, but share it amongst other campus buildings. And so we think that focus could go a long way towards reducing that minimal electrical load in the middle of the night. And it is a significant efficiency play.
Yeah.
Both in reduction, but also reuse. So it's like the, recycle, reuse.
Yes.
Right? Sustainability triangle, just from an energy standpoint. And
minimize what we do use, not get rid of the waste.
yeah, it's kind of cool, right? Like shout out University of Toronto in Ontario, Canada. They were the ones that really, their starting point from a decarbonization standpoint was to focus on their that air change per hour energy use in lab spaces.
Excellent. Okay. Well, I want to be mindful of the time, and I want to save time at the end for folks watching to ask questions. So I want to go back to the AEI baseline report.
Sure.
You said we're about half-ish way through before that final report is delivered.
Yeah, so they had sort of three parts to the plan. One was to, in essence, do a baseline assessment. That's done. And then I guess I should have put that under the wins category. And then we're right in the middle of this sort of project identification stage, and and that's generating some great conversations around everything from, you mentioned the tunnels. Obviously, principle, we want to use the tunnels where we can, but one of the logistical problems is that when we switch over buildings, you literally need to have the steam infrastructure there and the hot water structure there. So there's a real sort of, is there enough room in the tunnels for the hot water pipes? Short answer is most places, no. And yet you can't remove the steam pipes first before you put the hot water. Anyway, without getting into the weeds on that type of logistics of what's the most cost-effective way to get the new hot water system in place and minimize the amount of digging up of the campus that we would need to do is still under debate. And it's quite possible that we end up with a solution where we're doing a lot of what's called direct bury of the pipes. That will be very visible. So people want to know what's this going to look like, Dave? If you're in the southwest section of the campus or the western section of the campus, congratulations, you'll be first. No, look, we're gonna do our best to try to mitigate that in terms of its impact. That's one.
Okay.
And
was there anything from the report that you thus far, the discussions that you weren't expecting, or that has sort of been a change or an addition to the 5-part strategy?
That's a great question. I think overall it's really been reinforcing of the 5-point strategy with one piece that's come up. And frankly, it's come up in some of the public presentations we've had on our plan. People, probably one of the most common questions I get asked is, Dave, why are we not doing geo-exchange? And I actually got a flood of these questions in January. There was a big article in the New York Times highlighting the Princeton project, which is geo-exchange, and with lots of questions of, okay, how come we're not doing that? And the short is because the sewer and the lake options, which are unique to our particular local geography, are better in general than from a performance and from a cost standpoint than geo-exchange.
Where you'd have to dig a bunch of really deep wells.
A lot.
Yeah.
But one of the conversation pieces that's come out is the federal legislation, the Inflation Reduction Act, you'll be eligible for the direct pay provisions of the IRA if you do geo-exchange, and it represents over 50% of the heating load of the campus.
Okay.
Now that's significant. our campus is rather large, and 50% of the load, it's do we actually have enough space to drill the number of wells in order to achieve that? But sorry, it would make the geo-exchange cost, it would make the distribution piping and all of the new energy transfer stations in the buildings would all be IRA eligible.
And just real quick for folks that don't know what IRA is, the Inflation Reduction Act passed at the federal level would provide has major tax incentives for clean energy projects. So we would be beneficiaries of that.
And we could potentially get up to 50 cents on the dollar for a geo-exchange program. So at 50 cents on the dollar, geo-exchange is worth taking another look at. And really the only place on campus that would have the potential for that is the east parking lots. So we are adding that to the work that AEI, well, we've added it to the work that AEI is doing to have an assessment of could we get to the 50% threshold with the amount of space that we have available to us.
Okay, great. All right, so we've got about 15 minutes left. I've got another question for you, Dave, and then I think we'll take questions from folks online. So what is if you had to, I know there's lots of challenges ahead. Like you said, this is a marathon. This is not go to Lowe's or Home Depot and put it in over the weekend and you're done. What is one big challenge ahead of us with the energy transformation project?
Just one? I only can pick one.
If you have time, you can do two.
Sure. Well, look,
what are some of the biggest?
Well, obviously the biggest one at the moment is funding. Until we actually have the money in our back pocket, that's always going to be there. As much as we are very hopeful and excited, whether it's at federal or state level with respect to the opportunities that exist, and frankly, even internally with our own energy savings that we could drive out of either the reductions that from an energy efficiency standpoint or from a better performing COP on a heat pump, as I mentioned. So I've only said COP 4 times so far in this presentation.
That's your limit.
So that's one. I think another one is the upgrade to electrical infrastructure. As much as we want to, as much as we believe that we're going to be as efficient as we can with the choices that we're making and the strategy that we're doing, we are still moving from a summer peak to a winter peak, and it is still a new incremental electricity in the wintertime. Because it's electricity we're using and not natural gas. And so it's not just an electrons problem, it's a wires problem. The university also has issues with what I call power quality issues. When we have voltage sag events, the lights flicker for a quarter of a second. And then for the most part, everything seems normal. If you're a researcher and you got sensitive equipment, hopefully you got a UPS system that all your sensitive research is connected to and it's unimpacted by those voltage sags, which we get about 10 a year that are noticeable. We probably get about 40 that 30 are not. But different equipment is sensitive to these events, and a lot of our heating, ventilating, air conditioning systems are sensitive to the 10, and they trip off. And so as much as the lab equipment might still be running, the air system in the lab may not be, and it actually requires our staff to run out and manually reset. So anyway, bring it back. Knowing that we'll need to upgrade the electrical infrastructure to the campus, can we do it in a way that actually addresses this long-term issue? Place that I used to work, EVC, was on a transmission grid. We did not have this problem. And so my driver is, hey, we're a major tier 1 research university. One would not expect to have these types of disruptions from power quality. And so can we, at the same time that we upgrade to meet our decarbonization requirements, frankly, our climate adaptation and cooling requirements, can we also address this power quality issue at the same time?
Mhm.
So, but this is a big play, and a lot of conversations have already started with Seattle City Light. Very constructive, really, another great partner that we're engaging with. But this is in itself, an 8-year exercise that we've begun with them. And obviously, we're going to look for ways to how we accelerate that.
Yeah.
But that's another major. In essence, how do we upgrade the wires to the campus to meet our new requirements?
Yeah. Yeah. Okay, I'm sure we could go on for a long time about the challenges. But why don't we take a question or two from the audience? So there's been a couple comments in the chat. What about solar? So do you want to talk a little bit about solar as it relates to campus energy needs?
Yeah, sure. Well, in essence, as we electrify and we become, fully and even more dependent on Seattle City Light for electricity, any electricity that we can generate ourselves and mitigate that is helpful. And that's where solar comes into play. Once again, the Inflation Reduction Act offers tax credits for solar generation. So as an institution, we should be all over that. And perhaps the greatest opportunity, once again, is the east parking lots. So, we might have to get, depending on how the geo-exchange evaluation works out, get creative of a combination of geo-exchange and solar on the east parking lots. It'll be the energy hub for the campus.
Yeah. Okay. Thanks for that.
Sure.
Okay. So why don't let's see, we've addressed some questions about energy efficiency, and for folks online, I believe you're able to raise your hand if you have a question. Oh, okay, you can't. Put your questions into the chat, and we will try to address as many questions.
I'm seeing one there said, is there a digital strategy to drive sustainability? Yeah, absolutely. And I'd highlight that, one of the things that, obviously the better data that we have on how energy is used and where it is used can have such an impact on our systems. I'll go a little bit into the weeds. All right, a little bit into the weeds, which is the temperatures that buildings operate at. So, right now the steam goes out to buildings inside a mechanical room. There's a steam to hot water heat exchanger that heats the hot water in the building, and then that hot water goes around into the building, primarily for heating the space. And when we make this transition, the building itself, for the most part, their systems don't change. It's instead of having a steam to hot water heat exchanger in the mechanical room, it's a hot water to hot water heat exchanger in the mechanical room. And the temperature of the hot water on the building side stays the same. And with a couple of exceptions. So the couple of exceptions is, it turns out there's five buildings on our campus that actually have the steam go throughout the building into radiators into spaces in the buildings. And a couple of them are rather large. You might have heard of the Suzalo Library, or for those in chemistry, Bagley is one of them. But for those buildings, it's a much more complex switchover. But for the majority of buildings, it is not. And we're not changing the air temperature of the space. And we're not even changing the temperature of the water that's being circulated. We're changing the district temperature and how that transfers. So, anyway, it's kind of a subtle. Some people get like, what's is Woodson to save greenhouse gas emissions? Is he going to drop my temperature to 68 in my space? Is that the strategy? Like, no. But sorry, I was going back. Started with digital strategy. Digital strategy. Look, there's so much here, like that active energy management piece. There's a lot, I gave one example, but there's many different ways in which we can find and identify energy efficiency, and you can only do that if you have the data. And the other part of that we're wanting to do is, and we're working on this, is to not only as we improve the data that we have at the campus scale of all the buildings on the urban scale, but actually making a copy of all of that data and putting on an academic server and giving researchers and graduate students access to that data so that you can come up with ideas that we didn't even think of. You know, and how you analyze that data. And so that's another part related to, I know there's so much that you put into a digital strategy, but those are a couple of things that come to mind for me.
Yeah, the academic server piece will be exciting because we know that students and faculty and other folks really want easier access to that data.
It's another one that, once again, we did at UBC, and it was a huge success. And we go to these, you know, graduate student seminars where they're reporting out on their research, and we didn't even know. Obviously, when we made a copy, we wouldn't know that they're accessing our data, but we could tell when they were giving the reports based on the style of the reports that it was our data that was. So I'm convinced that there is a big appetite for that same information here, and we just need to create the platform to provide it.
Yeah, okay, well, that's exciting.
And we got to clean up the data that we have to make sure that it's accurate in the first place.
Yeah. This is all part of the strategy, though. This is
all in part one, totally.
And something that we've already started working on. Okay, another question is, will cooling be added to UW dorms? Is this a matter of just hooking the building up to the new system, or is there work inside each building that would need to be done? And this goes for some non-dorm buildings, just some academic buildings on campus too, that don't have cooling right now.
Yeah, no, great question. It is very difficult to add cooling to existing spaces that don't have cooling at all. It is much easier to, if you had spaces that either had their own chiller that was now undersized because it was built for a 1980s environment, that is way easier to make the transition with. But for spaces that don't have cooling, it really waits for when a major retrofit takes place and or building replacement takes place. There is a parallel plan to the energy renewal plan called the building renewal strategy to address deferred maintenance on campus, where it would do exactly that. It would go into spaces where buildings either need to be replaced or renewed, and that's where the two plans come together. And you know, we would not add cooling into spaces that don't have cooling until such time that building renewal plan it came along for that, you know, major retrofit.
Okay.
It's too, you wouldn't just do the cooling because you're having to modify pipes into every room into the space. And when in doing that, you would want to touch everything.
Yeah. And address a lot more issues at the same time rather than one by one and potentially adding to the cost. Yeah. Okay. So we've got, maybe this is our last question. We might have time for one more after this.
Sure.
Somebody's asking about, is there potential to use methane emissions from the Montlake landfill or some of the landfill landfills under the parking lots?
The old landfill that the parking lot is built on top of. This has come up in conversation. The amount of methane this has been dissipating over the years. There's a report that the university does every year to measure that at a number of different locations. My understanding is there used to be a lot more methane than there is today. We literally used to flare it off. If you can believe that. But there's not that same magnitude of methane anymore. And it's not like it's all concentrated at one location. And so that makes it really difficult to take advantage of from a reclaim or reuse volume standpoint. Rather, it's something that we do have to be very aware and cognizant of. If we were going to go down the geo-exchange option at Montlake, but so not saying no, but our initial assessments have been that it's not large enough or significant enough of an option, and not concentrated enough, and not of volume that the cost would be viable.
Yeah.
But it's something, hey, if we're gonna dig down on the geo-exchange piece, you know, how do we, are we gonna run into pockets of methane? But to be determined.
Yep.
And you know, there might be something there.
Yeah. Yeah. Okay. All right. Well, we are about at time here for our decarbonization webinar. Before we go, I want to ask Dave, for folks that, you know, really want to stay engaged and are interested in the steam plant decarbonization transition, you want to talk a little bit about how they can stay engaged?
Yeah, sure. Well, I'm gonna send them to your website to begin with, because the sustainability website's actually got a list of like all the different opportunities that are there, and the one that we've created as it relates to this project is a student energy task force and a faculty energy task force. And if people have interest and would like to be more involved, gladly have you join us for those. And
Yeah. All right. Thanks, Dave. Yep. Lots of information on our website, the energy transformation website that I showed at the beginning. You can also email the UW Sustainability Office, and we'll make sure to connect you with whatever group or opportunity.
I just saw a quick comment. Someone said, is there a staff task force that staff can join? And there is. Yeah, please just reach out to us, and we have a staff, student, and faculty task force.
Yep.
So
yeah,
all good.
Yeah, and encourage you to sign up for UW's sustainability newsletter, so you would find out about events like this or webinars like this, other events, you know, such as the decarbonization town hall that we partnered with Faculty Senate on last fall, to make sure that you're aware of all the different opportunities and discussions around this really important effort. So thanks so much, everybody. Dave, thank you for taking the time to chat with me and to talk with everybody.
This was tons of fun. Thanks, Lisa. It was great.
Yeah, agreed. Fun for me as well. So thank you all so much, and have a great rest of your day.